AI at our it's limited. So before I proceed with what I've been doing, I will have some questions for you. And based on the question, if you answer it correctly, we'll have some great goodies that we are going to distribute. Anyone knows about AI here? Please raise your hand. What do you think of the potential of AI? Does it have the potential to change the landscape, the IT landscape? Yes. I do believe so, yes. So let's have a look. So my agenda for today is we'll be talking about Industry 4.0 in the context of the textile sector. Why are we talking about AI now? Some use cases in the textile sector, because I'm coming from the specific textile industry sector. Some practical implementation, and of course, transformation of the textile industry with AI. So what is Industry 4.0? In fact, I do believe that we had Industry 1.0, 2.0, and 3.0 that had the capability to extend our physical limit, right? For example, mechanization. And now with Industry 4.0, we are able to extend our mental capabilities. That is, we are allowing computers to think, to see, to listen, and also to talk. For example, speech to text. Now, before I proceed further, I would like to ask you one simple question. What are the three basic needs of human? Can someone raise their hand and please answer? Sure. Clothing, shelter, and food. Right, so you please hand out the gift. So you do believe that clothing is a basic need, right? And hence, we do believe that textile is a major player in our work. So, according to a recent market report, the global elegant textile sector is expected to reach 5.5 billion by 2025, which means that textile has the potential to keep on innovating and applying AI to be able to become a major player. Now, why AI? Like I've told you, why AI now? Let's have a look. Today we have improvement in algorithm. With the democratization of AI, nowadays you can build AI in your own laptop. I do remember that when I was doing my PhD, I had to borrow a computer from the university to be able to train my AI. And worst of all, it used to take weeks, if not months, to be able to train an AI algorithm. And one incident happened to me is I was waiting, it went through 80% of progress, and then there was power cut, and I had to restart all over again. But now, with improvement in algorithm, I guess you know it, you have TensorFlow, you have Keras. Can you name me another platform, please? Sorry? PyTorch, yes. And PyTorch was developed by? Any idea? By? Facebook, right. It's good. So you did your homework before coming. This is one of the reasons why we have lots of application which is being developed nowadays, because you can develop application not only in your computer but also in your mobile phone. Second is big data, right? You have a huge amount of data that are being generated on a day-to-day basis. What do we do with those data? I guess by now, in the past, when social media started, we used to do what? Follow what our friends is doing, but also stalk people. Right? Now imagine you have an AI that can do the stalking for you. And this is possible with AI, of course, right? I delegate most of my tasks with AI rather than do it myself. And this is because we have big data that provides training capabilities to those AI. And of course, advancement in hardware. Today you have GPU, TPU, TensorFlow Processing Unit, and this was developed by, any idea? TensorFlow Processing Unit?
Google.
By? Please raise your hand so that we know.
Google.
By Google, of course, right? So TensorFlow was developed by Google, okay? And it allowed people to use their platform to develop AI application. And the great thing about it is the fact that it is open source. So, let's have a quick overview of some use cases that we have to explore, at least potential use cases in the textile sector. You have predictive maintenance, that is, before a machine breakdown, you can have an AI algorithm that can sense anomaly and then send you information about potential breakdown. Second, you have safer operational environment. I do know that one of my students, when I was a lecturer, was talking about how we can use computer vision to detect whether people are wearing helmet at workplace, which is hazardous. Third is human-robot collaboration. With the use of robotic process automation, I guess I've made a lot of people at Ordinance very happy, because right now they are not doing repetitive tasks. In fact, this has been delegated to RPA. You have quality 4.0, this is what I will be talking about. You have cost optimization. By exploring data, you can find hidden insight which can help to make your business more efficient. And of course, digital twin, which is something that is becoming more and more prevalent with the use of augmented reality and virtual reality. Now, some practical implementation at Ordinance. These are some applications that we have already implemented, or at least we have built some POCs. Because MLOps have a life cycle, we need to continuously monitor it, feed it with data, and achieve a certain level of accuracy so that we can effectively deploy it. So we've done fabric defect detection. This is what I will be talking about in a few moments. Speech to text, intelligent OCR, capable of reading different types of invoice and retrieving the same information. Market analytics using regression analysis, finding trends and patterns in customer sales, customer purchase, and with regard to the orders that we get. And of course, like I've said, robotic process automation, which has helped us to automate repetitive tasks. In fact, at Ordinate, we have at least 25 to 30 robots that are already working on a day-to-day basis to facilitate our life. So, what is fabric defect detection? Some typical defects could be hole, drop needle and line. And this is based on the garment that are developed on a day-to-day basis, which is used to make clothes for you. Would you like to have such defect on your dress? I'm sure no. So how do we find a way to eliminate that completely? Because like Mr. Kendall said, we need to have, in the past at least, we needed to have a human eye looking at the garment to be able to see whether we can spot defects. And most of the time, as people, we are bound to emotion, we are bound to tiredness, and we fail to at least spot a few ones. So, again, another reason for selecting this project to present to you today is based on 1,750 tons of fabric, almost 35 tons goes to waste. And this is huge. And since our objective, like Mr. Kendall said, is to move toward more sustainable development, I do believe that this project has a significant contribution in the textile sector. And the machine learning technique that we adopted is computer vision. Any idea here? Anyone who has already developed a computer vision? Face recognition? Yes? Now, how was our approach? One thing which I would like to share with you is we don't develop AI for the sake of AI. We don't just look at face recognition and we develop face recognition just for the sake of development. What we need to do is we need to take a design thinking approach. Now, what do I mean by that? Is to be able to understand the problem properly before deciding how to tackle the problem. Lots of time what happens is we have a problem, there could be a very simple way of solving the problem, but we think in a more complex way. In fact, our CEO likes to break down problems in a very simplistic way so that we can find ways and means to be able to solve it more effectively. So the first step was throughout understanding of the problem. I'll go through that in a few moments. Exploration of a wide possible range of solutions, iterate extensively through prototyping, and finally implementing through customary deployment mechanism. Now, what we did was we combined different areas of expertise. It's not just about AI, it's not just about engineering, it's a combination of different fields that we combine and manage to create value for the company. Now, Why this is important? I guess if you look at machine learning, specifically when talking to computer vision, it could be very simple. Just put a camera and just implement some CNN, okay, to be able to detect some issues, for example, the fabric defect. But the complexity lies in where we are applying. So if you look at this machine, you will see that it's not just a garment. In fact, it's much more than that. It's not just an AI problem, it's also an engineering problem. So if you look at this image here, you will see that this is where we take yarn and convert it into garment. And this is the source of the problem, rather than we wait for the garment to go at the quality control to be able to detect the defect. Our aim was to be able to identify the defect at source and stop the machine before it could actually keep on implementing, giving those types of defects. So, how did we approach that? What we used was custom labeling of data, that is Label Studio, right? Second is Streamlit. Anyone familiar with Streamlit? This provides an interface for our AI engine. And finally, we use PyTorch, and all of them are completely open source. So we did not use any API from AWS or any cloud service provider. In fact, everything was built in-house. The first step was to label data, and the image was captured locally. What we did was we used data augmentation technique to be able to make 100 data to become 1,000 data. Because as you know, deep learning is data hungry. And then the framework that we used was PyTorch. Now, our choice for PyTorch was based on the fact that it was portable. So we could just convert it into any types of, I would say, extension to be able to implement it very effectively. Now the training was done. In fact, I'll be a bit technical here. What we did was, once we gathered our data, we did a 80-20 splitting. So 80 went for training and 20 went for testing of the system. Would you like to see a demo? Sure. Yes. So let's have a look. Sorry. Hope it's working. It's a bit shy sometimes. Yeah. So this is at microscopic level. Were you able to detect it? Yes. Right. Let's assume there was no AI. Would you be able to detect it in this background? I do believe it would be very difficult. Sure, of course, because of the amount of data that we've gathered initially, so we were able to get a confidence of 0.43, not accuracy, I would say confidence, right? The AI can confidently predict with an amount of 0.43, but this is increasing on a day-to-day basis because we are feeding the machine learning algorithm with more and more data. I guess you know that, like I've said, deep learning is data hungry. So the more data we feed, the more confident the AI will be to be able to predict. But right now, we've done lots of testing, and the error rate at least was 1 in 100. So it's quite accurate. Now, at this stage, like I said, the model is monitored continuously. So we are trying to ramp up the accuracy by feeding it with more data. And we are working a lot with the engineering team to be able to capture data live from the knitting machine to be able to train our system. We've developed an interface, a basic